symbol means segment ST, which means it has a distinct endpoint on either side. And so we can label that as ST, but then we can also measure it, and we can know what the length of that segment would be. We could measure it to the nearest centimeter, we could measure it to the nearest eighth of an inch. Those are two completely different units, right? What units do we use in America? Yeah, we use inches and feet, right? If you went into Lowe's or Home Depot and needed the length of something or a board or something, we use inches and feet. We're like one of the few nations in the world that uses inches and feet. Most countries are in the metric system where they use centimeters and meters, and so I think, and it's kind of crazy, but I think there's only like 3 or 4 countries in the entire world that use inches and feet. Not very many, okay? If you Googled it, I might be wrong, but it seems like the last time somebody told me that, is that it's not very many. And so we're one of the few. Even though the U.S. is a really big country, we kind of just do our own thing, right? And so that's typically, if you're measuring something, inches and feet are the way to go. Because that, if you're looking at like carpeting, or if you're looking at like square footage, those are the units that we use. So you would take the ruler, you would label it up here, to make sure you're using the correct size, and you would say what the length of that would be. I'm not going to talk necessarily about what the length of that one is for right now, since I don't have my ruler up here on me. But when I see ST, then the way that we would read this is segment ST. If, and this is going to be the part that's going to be a little bit different, okay? If I see XY with no symbol above it, that is different than XY with a symbol above it. So we're going to read that differently, and it means different things, okay? If I see XY with no symbol above it, that means the distance from X to Y. How far would it be from this point to this point? If we're talking about an actual segment and we want to label a segment, then we want to label it with the segment symbol. Okay, so those are read differently and they mean different things. One has the symbol above it, one doesn't. If it doesn't have it above it, we're looking for the length of that. If it does have the symbol above it, we're actually talking about the figure, the segment part, and so they mean completely different things. Which one of those would give me a numerical value? Distance, right? Distance would be, we're going to say that is 6 feet or 6 inches or whatever it might be. A numerical value would be this one here. So when I look at this one, if I said find XY, the way that I would read that is find the length of X to Y, or the distance from X to Y, and my answer would be a numerical value, whatever label or whatever unit we might be using. A geometric figure is the segment, so that would be the symbol above it. Okay, so just different instances and different ways of using. It's got the same letters in it, so that's why a lot of people think, oh, it's the same thing, but really it's not, okay? And they mean completely different things. The ruler postulate means we're going to take a ruler to measure something, and so that would be the distance. Okay, if we're actually taking a ruler to something to measure something, then we want the length of that, or the distance of it. Okay, a word that you're going to see all year long is congruent. If I said 2 segments are congruent, congruent is another way of saying the same or equal, okay? And we'll use all of those words pretty much hand in hand with one another. 2 line segments with equal length or the same length, whatever, however you want to say it. So if I gave you a segment over here and a segment over here, then as long as they have the same length, we would say those 2 segments would be congruent. So here would be an example. Here's AB. Let's say AB is 4 centimeters. Let's say CD is 4 centimeters. So then what I would say here is I would say AB is equal to CD. And what I'm really saying here is the length of AB is the same as or equal to the length of CD. Okay? We know they're both 4 centimeters, so we know that they're equal to one another. The symbol for congruency, this is a symbol that we haven't ever seen before. So on this one, we're saying the length is equal to each other. Here, we're saying that segment AB is congruent to. So it's an equal sign, and this is what we call the tilde sign. You kind of see that sometimes like in Spanish, if you've ever taken Spanish, the tilde sign. It means congruency is congruent to segment CD. And we'll see this symbol a lot. This symbol means congruency, and you might want to put that in your notes. So congruency or congruent uses that symbol. Hey, another thing that we will do here is, and this is a common marking, and so we're just trying to show you a lot of things to kind of set up when you see it from here on out, okay? These two segments are congruent, right? We just said they're both 4 centimeters long. And so what will happen sometimes is you will see a marking on that segment like that. And since it has the same marking, it's like a little tick mark. Since these two have the same marking, they will be congruent. So if I were to throw up a segment here, and I put a marking on it, and a segment here, and I put a marking on it, okay? Do we know what the actual length of those segments are? No, but what we do know is they're congruent because it has the segment marking, okay? So we may not necessarily know the length of it, but we do know they're congruent, or the same length, okay? So symbols are going to be a really, really big thing in geometry. So we got to make sure we understand all these symbols and how to use them and that kind of thing. Okay, what we're going to do here is, and this kind of goes back to algebra a little bit, we're going to plot 4 ordered pairs. It's been a little while since we plotted some ordered pairs. It's one thing that's never going to go away. You're going to use that in pretty much every math class that you're going to see throughout high school. Okay, J is negative 3, 4. How do I plot the point negative 3, 4? What direction am I moving first? Left, okay? So we're going to move left 3. We always start at the origin, right? We're going to go left 3, and then we're going to go up 4. Okay, and then what we're going to do is label that with a J, point J. Kind of like we did earlier in the chapter. Okay, 2, 4 is going to go right 2, up 4. That would be point K. L is at 1, 3. So we're going to go right 1, up 3. M is at 1, negative 2. Okay, it'd be a good idea to label those points as you're marking them, because now what the next thing is going to do, it says make a segment with JK. So we're going to connect J to K. Make a segment with LM, so connect L to M, and that gives us 2 different segments. Okay, the first thing we're going to look at here is what's the length of JK? 1, 2, 3, 4, 5. LM, because they're horizontal or vertical, we can count. If they were like diagonal, we wouldn't be able to count. So as long as they're straight up and down or straight across, we could just count across or count up and down. This one, we would go 1, 2, 3, 4, 5. And so this one is also a length of 5. 5 units, 5 coordinate lengths. Okay, so once again, to talk about the terminology today, J, K is 5. I don't want a symbol above it because I'm saying the length of JK, the distance from J to K is 5. Same for LM. L to M is 5. The length from L to M is 5. So then what I could say is I could say JK is equal to LM. The length from J to K is the same as the length from L to M. Don't have a symbol above it. If I put my symbol above it, then I would say JK is congruent to LM. Those two segments are congruent. Okay. And what I could also do then is I could put that marking on it now. We know they're both 5, so I could go ahead and mark it and say those two are equal length. And so that marking shows me that. So sometimes they might give us that marking on there, and we already know that they're congruent, or in this case, we could even add it to that picture. Okay, next one. Okay, we're going to see a couple of different things like this. Today we're focused on segments. So today we're going to talk about what we call the segment addition postulate. The name pretty much tells you everything that you need to know. Okay? The segment addition postulate if I gave you a picture like this, and I told you that AB was 20, and I told you that BC is 30, can we find the length from A to C? Yeah, what would we do to find the length from A to C? Add them together, right? If I went from here to McPherson, and then I went from McPherson to Salina, I would just add those two together in mileage, and I would say, here's the total distance that I drove, right? Same thing here, segment addition postulate. If I know the length of two smaller segments, I can use those two smaller segments to find the big segment, okay? As long as they're connected and have that common piece in the middle. So as long as B is between A and C, then AB plus BC equals AC. A really quick and easy picture down here. Let's go A, B, and C. So we got 2, we got 5. AB is 2, BC is 5, so AC would be 7, yeah. That would be our length. Okay. Okay, so going down here, a couple of examples kind of using the segment addition postulate. Okay, how would we read this right here with no symbol above it, based on everything we've talked about today? When I look at this, how do I read it? Distance, right? When it says this, some people look at it and say, what does it mean, find DF? DF is right here. It's this segment, okay? We're not telling you to locate it. We're telling me, when I read this, I'm saying, find the distance from D to F. So we're finding the length, the distance, how long it is, okay? So we're going from D to F. We know that DE plus EF is equal to DF. The two smaller pieces add up to equal the big piece, okay? We're trying to find DF, the length of DF. Well, it labels DE as 23 in the picture. It labels EF as 35. So in order to find DF, what do I need to do? Add them up, okay? Add them up, it's as easy as that. 23 plus 35 makes 58, and that would be my length. DF is 58. We don't have a label right here, so a generic label that we would use is like U for units if we had to label something. If they wanted a label on there, they would say inches or feet or something else, but a generic label is always U for units. Okay, now on part B, it's a little bit different, right? We're still looking for the length of GH, but GH isn't the length of the big segment. GH is one of the smaller segments. So I would probably set this up a very similar way. FG plus GH equals FH. The two smaller segments added together equal the big one. We know 2 of the 3, we have to find the missing piece. But in this case, it's not the big piece. So we know that FG is 21. GH, we don't know it. So if there's something we don't know, what do we usually label it with? If we have an unknown. Yeah, we just use X, right? It's kind of back to algebra again. If we don't know what that is, we just say X. X represents something that's unknown. We don't know what it is. So we're just going to use X. So 21 plus something, plus X, equals 36. What would I need to do here to get X all by itself? Subtract the 21, okay? And I know that some of you could probably do that without writing that equation out. I mean, some of you might say, well, it's kind of common sense that those two have to add together, so we just subtract it. But I think in some cases it's helpful to kind of see it written out. So we take 36 minus 21, and we get GH equals 15. And that would be my missing piece. All right, looking at this map, cities shown on the map approximately lie in a straight line. So we've got these cities connected by a straight line. Find the distance from Tulsa, Oklahoma to St. Louis, Missouri. So we've got Lubbock in Texas to Tulsa, Tulsa to St. Louis, and we got 2 different distances given. We know the distance from Lubbock to St. Louis. We know the distance from Lubbock to Tulsa. We're looking for Tulsa to St. Louis. Okay, so that little piece right there is the piece I'm going to label with X. So we're going to say 377 plus X equals the total distance of our trip, 738. If I want to get X by itself, once again, same thing as we did on the last one, it's just a little bit bigger numbers, okay? So we're going to subtract 377 from both sides. So 738 minus 377, what's that leave us? 361. Okay, and on this one, we can go ahead and label it miles because we're talking about a length of a trip, distance of 2 cities on a map. Okay, this one takes us a little bit different direction. If the trip takes 6 hours, how fast are we driving? Okay, and so I think we're talking about this trip here because we're talking about Tulsa to St. Louis. and we talk about an average driving distance. So if we have miles per hour, if I figure out miles per hour, per means divide. So I would take 361 miles over 6 hours. Okay, and I'm going to use the approximate symbols because it's not an exact answer. It's about 60 miles per hour. Okay. Now, if I'm driving in a car from Tulsa to St. Louis, do you think that sounds a little bit crazy that we're driving 60 miles an hour? Do you think we'd be driving faster than that? Probably, right? I mean, I'm guessing, I don't know this for sure, but I'm guessing there's probably an interstate or a major highway. And so probably you're looking at a speed limit of at least 70. So you might say, well, why is this person only driving 60? Why is the average speed 60 miles an hour? Yeah.
It could have been some slower speeds, some
For
faster
sure.
speeds
Yep.
from one segment to another.
Yeah, absolutely. Yeah. I mean, if you have to go through a town, you might slow down, right? Maybe there's a wreck, something like that. And what do you always have to do on a trip? If I'm traveling for 6 hours, I don't know about you guys, but I can't travel 6 hours typically without stopping to get something to eat or drink or go to the bathroom or something like that, right? So that's going to go into your average drive time, average speed, because the total trip took me 6 hours, but right now we're not accounting for stops and other things as well. Okay, so it may not sound very fast, but in the big scheme, it's probably pretty accurate. All right, we're going to skip over the other map problem because it's not much different than the one we just did. Just different cities is all. All right, so this one is thinking outside the box just a little bit. Okay, here is what I would encourage you to do on something like this. AD is 40. So in geometry, here's one of the biggest things about geometry. In geometry, you're going to have given information. Information that is provided to us that we're going to use to help us answer the questions that are being asked of us. Okay? So we're going to take that given information, and especially in geometry, we're going to put it onto a picture because everything is about visual and being able to see things. And if we can see it, it helps us to understand it a little bit better, probably. So AD is 40. And what I like to do on something like this is the entire length, the big segment, is 40 units long. So I just draw a little line to shows from A to D is 40. I wouldn't want to write it right on top of the line because then you might get confused and say, which segment am I talking about, right? So that's why I like to do it up and above the big segment. Okay, what does this piece right here tell me? How would I read that? AB is congruent to BC, right? What's that tell me? If they're congruent. They're the same, okay? So here's what I can do. AB and BC are congruent. They are the same length. Those two pieces are congruent. Okay, AC and CD are also congruent. So this piece here and this piece here are also congruent. It's a little bit harder to label those two because you're going to put like labels on top of labels, but just kind of keep that in the back of your mind. That what's that tell me about C from A to D? If A to C and C to D are the same, then where would C fall?
Middle.
In the middle, right? Same thing here. B is in the middle of A and C. So if I know one of these, I know the other one because B's in the middle. Same thing for C. Okay, so here's what we're going to do. Let's label the pieces that we know. The first one, and you don't always have to go in order, right? A lot of people think I got to do this one first and then this one second. Well, not necessarily. Start with the easiest one. The easiest one is the one that's given to us. AD is 40. Okay, if the entire length is 40, what we just said was C is in the middle. It's half, right? So that means C splits AD into two equal parts, which means these two sides would both be 20. So AC would be 20, CD would be 20. Now we know that AC is 20, but what do we know about B?
It's half 20.
Yep. Okay. B is right in the middle of AC, right? So B is splitting AC in half. It's right in the middle of it. So that means AB is 10, BC is 10. What about BD?
30.
It'd be 30, right? Because we know this is 10, we know this is 20, So then that's the segment addition postulate where we're adding those two together. 10 plus 20 would make 30. So we just kind of break it up into pieces, use the information that we have, and help us to answer the question that we got. Okay, they're asking us a couple of different questions here, okay? Now on this first one, what is the probability that the measure of the segment is greater than 10? We have 6 different segments here, okay? So how many total segments do we have? We have 6. When we do probability, we do the number of things that we want out of the total number, okay? We have 6 total segments. Out of those 6 segments, how many of them are greater than 10? 4, yep. 10 is not greater than 10. Same thing here. These 4 are greater than 10. So 4 out of 6. Would we leave it like that? No. What should we always do with fractions? Always simplify. Take 2, yep, 2 out of, so 4 divided by 2 is 2, 6 divided by 2 is 3, 2 over 3. That would be our simplified answer, a 2 out of 3 chance. All right, here we go, last one. We do not have a picture, so we need to kind of provide our own picture here. And we got to still fit whatever specifications they give us. Points A, B, and C lie on a line. AB is 5, AC is 7. And probably the way that most of us would draw this picture would be this. And we know that AB is 5. And we know that AC is 7. So in this picture, what would the value of BC be? 2. Yeah. BC would have the length of 2. Okay. And the reason why I say that's the way that most of us would draw this is because that makes the most sense, right? Because alphabetically in our brains, A, B, and C. B's got to be between A and C. But it doesn't have to be. It never says up here that B must be between A and C, does it? Right? And so that's why we have to kind of think outside the box a little bit, and we have to think about another way that we can draw this picture. Well, if we know that, let's start with AB. The one point that both of these segments share is what? A. Okay? So here's another way I could draw this picture. Let's put A in the middle. I could go A to B. And I could go A to C. If A is in the middle, that means we could go to B here and C here. Now, what would the length of BC be? Close. Yep. 12. Okay. 7 plus 5. Okay. So don't get stuck in this is the only way we can draw it. Sometimes there's more than one way it can be drawn. And what it's asking here for is what are all possible values. So if all you said was 2, you'd have half the answer, right? We've got to list both of them out because 2 is only one of the possible answers. We actually have 2 possible answers here. So just be careful about things like that. The way the questions are worded sometimes is a little bit different. Okay, that's it for segments today. Segment addition postulate. Assignment should be up. You guys can go ahead and open up and get started